Dear student, I'm going to start the chapter 18, which is a big topic and very important from the exam point of view. The heading is Magnetism and Electromagnetism. So total there are around 7 topics. In this video we're going to talk about only 2 topics. So let's start. So before going to that, the regarding a small history of the magnetism. So the ancient Chinese, okay, the first discovered that there was a ideal stone like this. You can see here. So ideal stone, basically what they were observing, that whenever they suspended in the air, it always have a particular direction, north side direction. So why it is that? They have start searching that why it is that. Then further they have found that, oh, it's a natural magnet. Our earth also behave a natural magnet, okay, which have basically, if you think, if this is north pole, this is the south of the internal earth magnet what we have. Why it behave like a earth magnet? Because it is enriched with iron, cobalt and nickel. Okay, because of these are all magnetic material, the earth behave like a magnet. So that's why whenever you suspend a small compass or magnetic material, it will always suspend in this direction. So north pole of that magnet will come in this direction, because in the earth the south pole is here. I hope this is clear now. So let's talk about what are the magnets. So magnets are basically, you can think that are materials which have some properties, like it can attract, it can repel to magnetic materials. So let's talk about magnetic materials are the material that can attract to a magnet. Then non-magnetic material, just reverse it, that cannot be attracted to a magnet. Let's see some of the example, because sometimes exam they can just ask you randomly that steel is a magnet or non-magnet, and sometimes we just get confused that we think that all metals are magnetic, but it's not like that. For example, the copper, even though it's a metal, it's a non-magnetic material. Why? Because it cannot be attracted to the magnet. Okay, just now I've discussed about iron, cobalt, nickel. Okay, just add one more thing, which is a steel. What is a steel? It's alloy of iron and carbon, some percentage. So obviously if you have iron, it should be a magnetic material. Now further, what they're going to try and show you, that very important, the magnet, these are very important properties of magnetic material. So first part, that a magnet has two poles. Two poles means basically they are polarity. Both are completely different. If you sprinkle some of the iron fillings, which are very tiny fillings like our hair thickness, if you just randomly sprinkle, they will organize in particular direction. Okay, one this side and one this side. This side is very less, or you can say negligible. So you can say that basically the irons, which is a magnetic material, it basically why it is attracted, because it has the two poles on the magnet, which is very clearly, and they got attracted towards that. So magnetic effect are the strongest at the poles. Very important point. Now what is the second property? Second property is that a freely suspended magnet come in rest in north south direction, which just now I covered it. So whenever you suspend any bar magnet, we always represent the north side with a red in color, and it always suspended to the one pole, which is north pole, and just opposite end will be the south pole, because every magnet has always two pole, north pole and south pole. So this is the second property, and this is what we use for the compass. What is third property? It is similar like a charge, like positive charge repel each other, positive negative charge attract each other. So when you bring a magnet which have different pole, they will attract each other. But when is the different they have same polarity, they will repel each other. So wherever you see all these three properties, you will say that yes, it is a magnet. If it is not, it means you say okay, these are not magnet. So how the magnet can be identified? If you see, suppose if I'll given you just a simple box or block, okay, and nothing is labeled, it looks heavy, so it can be metal, but what, it is a magnetic material, it is not. So how to find? So whenever attraction can occur between the two magnets, just now we have discussed, or it can happen between a magnet and a object that is magnetic metal but it is now unmagnetized. However, the magnetic repulsion can occur only and only between the magnets. So suppose if I have given you unknown product, unknown object, how to figure out? So what you have to do, move one end of the object near the pole of the suspended magnets. So you can, if I have given you one object, you can just fix A and B and you put this near the suspended magnet. If this is repulsion, it means obviously it will be magnet. If it is attractive, you can think that it can be magnet. So what you have to do now, move other part end of the object near the same pole, and then you'll see if it is repulsion, then you'll say yes, it is magnet. But if it is attracted, it means it is a magnetic material, but now it is unmagnetized, so it is not behaving how the magnet should behave properly, that they are repelling each other, you have same pole. And if remain stationary, it means it is a non-magnetic material. So in this 18.1, what we have covered till now, we have covered that property of magnet. These three are important property of magnet, that it should have two poles. Whenever you have suspended, it should have a north to the north pole, and the like pole should repel each other and unlike pole attract each other. Now let's have question. So first question, they are asking you, give three example of magnetic material. Just now we have discussed, you can think of, just now we have discussed that it's a steel, iron, cobalt, nickel. What is non-magnetic material? You can add a very simple one, what we see every day, like wood, plastic, brass, paper, like that. Okay, state the property of magnet. Okay, so all these answer, if you want, you can give me the in the comment box this answer. This is very simple. Okay, coming to the question number 3. This is the set, and they want how they are organized, the poles of this magnet. So very important clue here is that the ring magnets are found to float on top of another, means every one is floating. Floating means what? Basically it's a repulsion. So whatever pole they are facing, they should be in opposite direction. So suppose if it is the south pole, this should be south pole. So obviously it will be north, then it should be north, and again south pole. So they should be behaving in a different place, in different in the same pole, so that they are not attracting, they are floating. Now question number 4, how would you test a steel bar to find whether it is magnetized or not? So if you know it is magnetized, it means if it is suspended in the as a free, it should suspend to the north south direction. It is suspended, it means yes, it is magnetized. Now if I'll put this steel bar near a magnet, which I know it's a magnet, and if this is showing the property of repulsion with the magnet, or the attraction, it is magnetized, because it is showing the property that okay, they have similarity the pole. So you can test based on the pole similarity, attraction, repulsion. Now second point is about the magnetic induction. Induction means what? Induction means basically you're influenced with something. So here they are talking about induced magnet. It means this was a magnetic material, okay, but when it come in contact with some permanent magnet, it has got some magnetic material. It means it is induced, it is influenced, and that is called magnetic induction. So magnetic induction is a process where object made of magnetic material becomes a magnet. You cannot reinduce magnetic material in non-magnetic material. Very important point. Okay, how we do? When you just put near the permanent magnet. So we will learn further, there are different method how you can induce. So in this example, if you see, this is your magnet. Okay, this is a permanent magnet, and these are the paper clips which are basically a non-magnet. But when you have put near this clip can attract another clip. It means they are behaving like a magnet, which is induced. So this is called magnetic induction. Now let's talk about this question. Okay, so this is a question you can try solve without looking the solution. This is a magnet, this is a needle, this is X, Y, Z. And what is the question they are showing you? That about to attract the iron needle. So this is about to attract the iron needle. It means what? It has different polarity. So if you have a north pole, it should have south pole. Okay, now what are the poles induced in the needle at the point XYZ? Obviously, if this is a south pole, this will be north pole and north pole. Why it should be south pole? Because this is given in the question that the north pole of magnet is close to the center of the needle. Okay. No, the hint is here. So a magnet that is about to attract an iron needle, if it is attracting, it means it should have a opposite direction of the opposite pole. It should be there. So this is the answer. If you think this is the south, so obviously it should behave like a north and north. Okay, now let's see the another example, question number 1. Okay, so till now what we have learned, magnetic induction is a process where a magnetic material become a magnetized when they are near or contact with a permanent magnet. Very important. Okay, now let's see some of the question related with this magnetic induction. So question number, as you can see here, in an experiment, a piece of wood is held between the north pole of a magnet and 2 iron nails. Okay, although wood is a non-magnetic material, the 2 nails are still attracted to a magnet. Okay, so this is wood, which is a non-magnetic material, correct? Now question they are asking you that, okay, if this is a non-magnetic material, how the iron nail is attracted? So you can think and take a pause and think of it. So basically, if you think about the magnetic force, they are non-contact force. Okay, what are the other non-contact force? We have electric force, we have gravitational force, where you don't require a contact. It can be induced here. For example, that if this is the permanent magnet, it can induce the other magnetic material to behave like a magnet. So okay, this is a wood which is non-magnetic material, but the magnetic force which is acting between the magnet can induce this iron nail to behave like a magnet. So this is what you can write, that yes, wood is a non-magnetic material, but the magnetic force can induce the iron nail to behave like a magnet. That's why it can attract to the magnet. Now question number B, it is observed that the pointed tips of the iron nails pointed away from each other. Obviously they are showing the property of repulsion. It means what? It means they both have acquired the same polarity. So if this is the north, this will be the south pole, and this will be behave like a again north and north. So that's why they are going to opposite direction, because they are away from this and they will behave like a north polarity. So next class we are going to discuss about the 18.3, because I don't want this chapter or video to be very long. So we are going to talk about 18.3 and 18.4. Let me know your review. Thank you.